Every new generation of wireless networks delivers faster speeds and more functionality to our smartphones. 1G brought us the very first cell phones, 2G let us text for the first time, 3G brought us online, and 4G delivered the speeds that we enjoy today. But as more users come online, 4G networks have just about reached the limit of what they're capable of at a time when users want even more data for their smartphones and devices. Now we're headed toward 5G, the next generation of wireless. It will be able to handle 1,000 times more traffic than today's networks, and it'll be up to 10 times faster than 4G LTE. Just imagine downloading an HD movie in under a second, and then let your imagination run wild. 5G will be the foundation for virtual reality, autonomous driving, the Internet of Things, and stuff we can't even yet imagine. But what exactly is a 5G network? The truth is, experts can't tell us what 5G actually is, because they don't even know yet. But right now there are 5 brand new technologies emerging as the foundation of 5G. Millimeter waves, small cells, massive MIMO, beamforming, and full duplex. First up, technology number 1, millimeter waves. Your smartphone and other electronic devices in your home use very specific frequencies on the radio frequency spectrum, typically those under 6 gigahertz. But these frequencies are starting to get more crowded. Carriers can only squeeze so many bits of data on the same amount of radio frequency spectrum. As more devices come online, we're going to start to see slower service and more dropped connections. The solution is to open up some new real estate. So researchers are experimenting with broadcasting on shorter millimeter waves, those that fall between 30 and 300 gigahertz. This section of spectrum has never been used before for mobile devices, and opening it up means more bandwidth for everyone. But there is a catch. Millimeter waves can't travel well through buildings or other obstacles, and they tend to be absorbed by plants and rain. To get around this problem, we'll need technology number 2, small cell networks. Today's wireless networks rely on large, high-powered cell towers to broadcast their signals over long distances. But remember, higher frequency millimeter waves have a harder time traveling through obstacles, which means if you move behind one, you lose your signal. Small cell networks would solve that problem, using thousands of low-power mini base stations. These base stations would be much closer together than traditional towers, forming a sort of relay team to transmit signals around obstacles. This would be especially useful in cities. As the user moved behind an obstacle, his smartphone would automatically switch to a new base station in better range of his device, allowing him to keep his connection. Next up, technology number 3, massive MIMO. MIMO stands for multiple input, multiple output. Today's 4G base stations have about a dozen ports for antennas that handle all cellular traffic. But massive MIMO base stations can support about 100 ports. This could increase the capacity of today's networks by a factor of 22 or more. Of course, massive MIMO comes with its own complications. Today's cellular antennas broadcast information in every direction at once, and all of those crossing signals could cause serious interference. Which brings us to technology number 4, beamforming. Beamforming is like a traffic signaling system for cellular signals. Instead of broadcasting in every direction, it would allow a base station to send a focused stream of data to a specific user. This precision prevents interference, and it's way more efficient. That means stations could handle more incoming and outgoing data streams at once. Here's how it works. Say you're in a cluster of buildings and you're trying to make a phone call. Your signal is ricocheting off of surrounding buildings and crisscrossing with other signals from users in the area. A massive MIMO base station receives all of these signals and keeps track of the timing and the direction of their arrival. It then uses signal processing algorithms to triangulate exactly where each signal is coming from and plots the best transmission route back through the air to each phone. Sometimes it'll even bounce individual packets of data in different directions, off of buildings or other objects to keep signals from interfering with each other. The result is a coherent data stream sent only to you. Which brings us to technology number 5, full duplex. If you've ever used a walkie-talkie, you know that in order to communicate, you have to take turns talking and listening. That's kind of a drag. Today's cellular base stations have that exact same holdup. A basic antenna can only do one job at a time, either transmit or receive. This is because of a principle called reciprocity, which is the tendency for radio waves to travel both forward and backward along the same frequency. To understand this, it helps to think of a wave like a train loaded up with data. The frequency it's traveling on is like the train track. And if there's a second train trying to go in the opposite direction,